Excellent, excellent. So, well, it's really a pleasure to be here, and I'm sorry that I'm not able to join you in person. And it is morning here, so I'll do my best to pep things up a little bit. And so let's get right into it. So, um, I guess we'll be switching gears, at least from the talks that I hear, and digging in a little bit into biometrics. Biometrics is one tool and a whole set of tools that can be useful when it comes to an identity infrastructure. And so, of course, people are well aware that biometrics can be spoofed. And so I just want to talk to you a little bit today about that and how we can address these issues and why these issues might be different than other types of hacks, in terms of the way that we can address them. So there's been actual attempts at fraud over the years, using fake fingerprints and other types of spoofing. And I'm sure you've heard of some on your own in various news outlets. And so some of them are related to border security, like this middle one. This one's for time and attendance. This one's for taking exams for each other. And so, if there's a security protection, there are people looking to fool it. So something that was said actually quite a while ago, in 2001, as biometrics began to be more used, is that it's really not about secrecy that we should be focused on when it comes to biometrics. It's about the liveness. And that's what's the special aspect of biometrics, is that you have a sensor, whether it be a camera or a fingerprint sensor or whatever, a behavioral biometric. It can measure the humanness nature of us. Whereas a keyboard, minus maybe some behavioral characteristics that can be derived, a keyboard is just textual information, right? It doesn't have the human aspect to it. And so biometrics adds more layers to it than simple textual pieces of information that we have commonly used. That secrecy is not so important. We use face recognition very ubiquitously now, and why? That's not a secret, yet it works, reasonably well in many use cases. And we'll be talking about how we can make sure we harden our biometric systems, against various types of attacks. So essentially, I posit to you that biometrics is not simply about the comparison, which is the first thing people look at or think about, right? Comparing an enrollment to a subsequent capture, but it's the combination of the comparison and the liveness. Did I actually capture that biometric from a live person at that time and place? And that's the value that biometrics can provide to give you that, yes, it does match the reference, but also I know I captured it from a live person. So we have to mention some vocabulary. The International Standards Organization has quite a few standards around biometrics in their SC27 group. Sorry, I don't know why the automated thing is going forward. And so spoofing is something called presentation attacks, because you're actually attacking at the time you're presenting. And presentation attack detection is detecting those attacks. And so liveness is one subset. And so if you hear people talk about PAD or presentation attacks, I just want you to be able to associate them with the larger concept of liveness. So presentation attacks are attacks at the sensor as we're presenting our biometric. That's why they call it presentation attack. And presentation attack detection is the detection of those attacks. And so this graph is really showing some various attack points throughout the biometric lifeline and or tool chain or flow chart and pipeline. That's the word I'm looking for. I guess it's morning for me, but I'm not fully on. And so we need to be thinking about security, of course, of our systems throughout the pipeline. And so we're going to highlight a couple of cases of biometric-oriented solutions like liveness detection that help with protecting in the pipeline. So the PAD definitions actually divided the types of ways to do liveness into three categories. So one is, we'll talk about challenge response first. So two of them are challenge responses. And so this is some kind of thing that the device or whatever the system is does that then causes a response by the person. So it could be an involuntary response, like a change in light, changing your dilation of your pupil, or it could be a voluntary challenge response where you're asked to say something. And so these aspects can be a important part of this liveness broader category of determining there's a real person there. And then there's also ones that kind of float in the background. We might call them passive, and they are not requiring the user to do something, but they may be based on being able to detect the material of a particular fingerprint spoof, or being able to recognize characteristics of what makes someone live based on the signature that is provided through the sensor. And I've defined these because I'm going to come back to them in a little bit. So the iPhone, quite a few years ago, released Face ID. People tried to hack it, and were only moderately successful. And as you know, it's been reasonably effective in terms of a way to get on your device and a way to actually have your device prove itself to a relying party. And what do they have inside to protect against spoofing? Well, they are taking advantage of the fact that they have control over the phone. So they have sensors that they can add. So there's a near infrared camera. There's a near infrared light that projects a depth map that you can't even see, but is there. It puts together a device-specific random pattern, which is, somewhat like an involuntary challenge response. There's light reflecting off your face in a certain pattern. And then gives you some 3D information. And of course, there's the visible light camera. So they have all of this embedded into the system in order to protect against spoof attacks. So, that being said, that's just one system, right? So biometric systems, face, fingerprint, and others are being used in many, many, many scenarios. So the question is, are they effective, right? And so, we have been doing research in how to evaluate liveness or presentation attack systems, as well as helping others set up certification programs. So this is just some examples of some of the spoofs that we make in our lab, and we're continually evolving the spoofs that we create and for multiple modalities. So we also run competitions. So for those that are academically inclined or companies, they can actually participate in our competitions. We recently gave the results for an iris competition and a fingerprint competition in a recent conference last week. And the data sets that result from those competitions are made available to researchers and companies that can be used to train and evaluate their algorithms. And we've collaborated with many other universities as part of these competitions. And here's just some example of those data sets. We've filled requests from around the world for copies of the data. And as you can imagine, creating these kinds of data sets, we're physically creating spoofs and then capturing the images is very time consuming. So we're very proud of the impact that we've had around this work. So how well is it working? So the industry is evolving. We've been doing competitions since 2009. So here's a graph of the performance of the systems as time has gone on. And you'll notice, kind of somewhat of a downward trend and then a come back up. And, when you're working in the world of more of cybersecurity, right, when we're being an attacker, we're actually trying to make our test harder as time goes on. So it's not really a fair thing to say, okay, we've really improved, because I think if you would go and look at maybe the results of on the earlier databases, that, you know, research shows that they're doing very well, but now we're making the data, the types of attacks harder, and not revealing as much about what the attack will be to the competitors prior to the competition, and thus the performance is not as good. All right, so we've talked a lot about physical attacks, but we know in this world with generative AI, digital attacks are becoming the bigger issue when it comes to biometric technology. And why is it an issue? An issue is because it actually could make someone appear to be live, right, by animating them when they really aren't. And we would call that face swapping is a general term for it, you know, or puppeting, where you're actually making you know, putting the identity that you're attacking face onto the attacker's face in order to fake the system. And this was a famous deep fake from quite a few years ago. They did use an actor, looks very much like Tom Cruise, but you know, it's quite amazing that the work they do, though they did spend a good month, I think the creator said, to actually create this particular deep fake. But as now years have gone by, you don't need a month anymore. In fact, it becomes quite a scalable attack. So I do have an example of a deep fake just for fun and to liven things up a little bit. This is a famous scene from a famous movie. Let's see, should I have done something with sound? Maybe, let me just make sure. I might have had to click something. Screen, yeah, share sound. Let me do that again. Okay, let's just make sure.
Don't you? Yes. All right. I understand. Fine.
All right, were you able to hear the sound okay?
We got the gist there.
Okay.
Unless you want to replay it again.
Oh, okay. Well, I'll play the deep fake. Let's see if it works. Oops, that's not it. There we go.
Don't you? Yes. All right. I understand. Fine.
You got the gist there. So
yeah. The deep fake worked better than the real one, right?
Okay, good. All right. I think you get the idea here that you know, famous scene from Star Wars, and of course I was a young girl when this movie was first released, and a huge fan, and it's just fun to live out maybe one of my dreams here with the deep fake. But it's quite easy, as I said, to scale these type of attacks of face swapping to put, you know, if someone wanted to target my identity and make me say or do something that I didn't say or do, we can scale these types of attacks. So all that's to say is our biometric security needs to anticipate that these kinds of things can happen. And so going back to our biometric security graph here, what is happening here? Well, you can present the deep fake physically in front of a phone, where you would put a phone in front of a computer, for example, and play a deep fake to the phone. And that really is, you know, a similar type of spoof attack, right? So all of our methods for, so that'd be an example of that: presentation, attack detection, and liveness, which work for this type of, it's almost like a physical attack, basically. It's a digital attack that's converted to a physical attack that then is presented to the phone by displaying it on the screen. So we're not super worried about these kind of attacks, because I think systems can recognize this kind of thing. I think the bigger worry is what we would call an ejection attack. So an ejection attack means we've somehow bypassed the camera or the sensor, whatever it may be, to insert something digitally. So what you're doing is you're acting as if you're sending a real stream from a camera, but you actually aren't. And so that's the attack. And that's where you can inject really actually a real video of somebody if you wanted to, or you could attack a deep fake where maybe you anticipate that there's some kind of motion that is needed and make that motion happen with your deep fake video. So there is protection here also. And this is why originally I came back to discussing challenge response, because challenge response is something that the deep fake creator can't necessarily anticipate. It depends on the challenge response. And so, for example, projecting a random pattern on the face, might be something that the deep fake, if it's random each time, wouldn't be able to pre-anticipate. And of course, there are work out there that is job is to recognize those artifacts that today come as part of deep fakes, maybe won't always come, but can be used to digitally recognize that a deep fake attack has occurred. And so this is very similar to presentation attack detection, and the fact that, challenge response is one of the solutions, and some kind of detection related to deepfakes is a possibility, but they're a little bit different in the sense of how you test it is different, because how you test it means you have to break into in order to bypass the sensor, in order to do the injection. There was no standard until recently. There's been a new work group that's set up. And of course, part of this protection involves, making sure that the ejection doesn't happen to begin with, but also then if it were to happen, how to detect it. So I'm going to switch gears just a little bit and talk about a use case for biometrics that is emerging from something called the FIDO Alliance, which is an open industry association working on replacing passwords as a primary form of authentication with something called passkeys, which I'll come back to. So this is international organizations with many of the global tech leaders. This is board level here, but hundreds and hundreds of sponsor associated liaison members that include companies and governments and academics like me. So, the idea is that today's security systems, whether they be passwords or one-time PIN codes, are weak, often very phishable. And the solutions, like things like security keys, are strong, but really poor usability. And so how can we sort of get beyond it? And FIDO passkey relies on public key cryptography, which I'll explain briefly. And it's easy for the user as well as phishing resistant. So how does it work? Oh, this is not how it works. All right, so first, let's talk about the life cycle of, I got to remember I have a slide that tells me what slide's coming. And so so passkeys are really, they're key to the user authentication step, but there's a whole life cycle that comes to identity that includes account enrollment and identity verification, as well as account recovery or identity re-verification if you have a lost device or on a new device, etc. And so these are basically some lists of all the types of attacks that can happen at each of the stages of being only knowledge-based, attacks that can be on biometrics, authentications, things like phishing, and then account takeovers that can happen during the recovery stage. And so, what we at FIDO are working on is passkeys, as I mentioned, which I'll give you a little more detail about, but also account enrollment through certified products that based on biometrics, as well as account recovery processes that can also be based in part on biometrics. And so these certified products, vary, including certification for biometrics, but as well as certification for the actual passkey systems. So just because this is talk on biometrics, I'm going to dig just a little bit more into the biometrics. And it looks like I didn't define the passkey, so I'm sorry, but passkeys are related to proving yourself to your device using biometrics, and then the device proving itself to relying party through public key cryptography. So here is the certification programs we have. We have certification for methods that determine the authenticity of a government-issued ID. Now, these are not certification related to public key cryptography methods, which have their own certification processes, but more relate to digital methods. If you have, say, a photo of a document and you're trying to validate it, which are, depending on the use case, one that can be used. And then face verification is matching your face against the identity document, and that could be a digital version of the face that's extracted from the document, or even a photo of the document that has a face on it. And then we have our biometric certification for any other type of biometric one-to-one comparison. So these certification programs are all based on those ISO standards. They're developed by leading industry stakeholders from around the world, and they are implemented by an accredited set of laboratories from also around the world. And so what do they test? They bring in actual real people to test metrics related to biometrics. They're called false accept rate, false reject rate. They do create spoofs, and they follow all the processes that we've mentioned here. So for example, this would be the types of fingerprints that would be created, fingerprint fakes that would be created and tested against the system. Right now, it's mostly these A and B setups. We also have an optional certification program that looks across varying demographics, because as you probably are aware, biometrics, some systems of biometrics have been shown to have variable performance depending on the demographic group. And so this program can help make a check across varying demographics. So that's my little segue about passkeys, just to make you aware, as well as tell you about our certification programs. Certainly, if you are in the business of creating requirements, this is something you can point to as a way to ensure that the products that you are purchasing meet some minimum requirements in terms of biometric performance. So just kind of finalizing and wrapping up, just to make you aware of some other things. There's the Biometrics Institute, and in the Biometrics Institute, they have a lot of resources in order to help with biometrics. I think the prior talk before mine, certainly as it relates to biometrics, use cases, there's a lot of sort of questioning in terms of society. And so the Biometrics Institute, here I'm focused particularly on the vulnerabilities, but I have another slide related to other good practice material that is available, including privacy guidelines, digital identity, good practice framework, and other aspects. And so, I, as a technologist, participate in work like the Institute, as well as other organizations, in order to help build a good ecosystem for biometrics. And so this is where I will wrap it up. And so just to summarize, presentation attack detection, that's our liveness. It's really two parts. Biometrics plus liveness equals success. And then we talked about injection attacks that bypass the biometric sensor, which are digital attacks. how they're similar in many ways to PAD, but have a different purpose, and are tested differently. And then we talked about certification programs that relate to biometrics, that include both live testing, spoof testing, and fairness evaluation. And I really thank you for your time and the opportunity to speak with you today.